Alright, so this is the third video in the set of 4 videos that are just going to walk through your Blue ACT prep book and just kind of go through some of the topics. This one's about geometry and measurement. As you can see, there's a bullet-pointed list of what this whole section covers, and we're going to talk about some of these things. But as always, if you see something as you're going through, pause the video and read it more thoroughly, because I'm not going to be going through every little detail of this thing. Alright, one of the things that I want to make sure you see is that what the SAT does not include, there's no formal geometric proof, so your geometry proofs from Geometry Honors or Geometry CP are not on there. There's no trig, there's no SOHCAHTOA, and there's no radians. Okay, so all these things that you guys maybe spend time on in geometry, these are not going to be covered in the geometry section of the PDF. The first thing that this review talks about is geometric notation. It's good to review some of these things. So obviously, if there's a line PE, segment PE, PE is just referring to the length of the segment. Ray PE, Ray EP, these are different. Okay, so understand the difference between Ray PE and Ray EP. If that's a question that you have, obviously we can talk about that. Angles, this is referring to the object, and this is referring to the measure. So the object angle is referred to as angle DOC. The measure of that angle is clearly M angle DOC. Triangles, quadrilaterals, perpendicular lines, just some common notation there. Points and lines, you can read through this. Basically, a point can be on a line. Points that are on the same line are considered collinear. There's some examples. Angles in the plane. One of the key things, some phrases, vertical angles and supplementary angles, vertical angles and linear pairs. Obviously, 65 and x are vertical, so 65 equals x or x equals 65. Same goes for 65 and y being supplementary. These are what you refer to as a linear pair. So just some things to think about, some things to recap. Keep going. Triangles, special triangles. We'll talk about equilateral triangles. When you're talking equilateral triangles, all the angles are the same, and it shows you all the angles are the same, and all the angles of factor 60, because all the angles add up to, all 3 angles will add up to 180, which makes them all 60 when dividing 180 by. Special right triangles, isosceles. In this case, when you look at an isosceles triangle, you know that the base angles are the same. So these 2 angles are always going to be the same in an isosceles triangle, just as these sides are always the same. In geometry, you might have learned a theorem that just says if sides of a triangle are congruent, then angles. Okay. And then it goes the other direction. If angles and sides. So these are true. That's the idea behind isosceles there. Moving on, right triangles in the Pythagorean theorem, probably the most famous theorem that you learn in geometry, Pythagorean theorem. I don't think I need to spend 30, 60, 90, and 45, 45, 90. You might want to take a look at these and look at some of the examples, but the pattern is always the same. The short leg is x, the long leg is x root 3, and the hypotenuse is 2x. So that's going to be however your teacher, when you learn geometry, taught you to remember that. That's key. The other thing for 45, 45, 90, again, the legs are both the same. They're both x, and then the hypotenuse is x root 2. So 45, 45, 90, 30, 60, 90, definitely worth a look if you want to take your time and recap those. All right, 3, 4, 5 triangles, your Pythagorean triples, 3, 4, 5, 6, 8, 10. These pop up all the time. So if you see, 3x, 4x, 5x, any number, any x that goes in here can make another triple. So 6, 8, 10, 9, 12, 15. There's, an infinite number of triples that you can create from that one alone. Congruent triangles, you might see something that's congruent. There won't be formal proofs, but the idea of triangles being congruent does come up. Similar triangles. Similar triangles are triangles that have the same shape but are different sizes. Their sides are proportional. Their angles are the same. So x equals x, y equals y, but the sides are in the same ratio. So what that means is like 16 corresponds to 8, if we circle those, just like 10 corresponds to 5. And you see that like 16 over 8 makes 2, 10 over 5 makes 2. So angles are the same, but sides are in the same ratio. So that's going to be clear. Triangle inequality is kind of key too. Because if one side is bigger than another side, then the angle opposite that side, for example, this one's opposite 13, that's going to be bigger than this angle opposite the 9. So when I do this, I circle, this one's going to be bigger, so put a plus next to it. So any way you remember it, but the angle opposite the bigger side are bigger. And also the inequality theorem that this one's talking about, if I could erase this, it typically says the third side can be only a couple things. Like the third side can't be a million. The third side has to be smaller than the difference, or smaller than the sum but bigger than the difference. So the sum of 9 and 13 is 22. So it's, if you see this down here, you see like 9 plus 13 has to be greater than DE, and it also must be less, or must be bigger than 4 on the next page, I think. So looking at this, quadrilaterals, parallelograms, rectangles, squares, all these things. Good review, okay? They all have their own specific properties. Parallelograms have 5 properties, rectangles have right angles, squares have congruent sides and right angles. Notice that when you have a square, you cut the diagonal, it makes 45, 45, 90. That's a key topic. Area and perimeter, a bunch of cool formulas, good formulas to remember. Unlike the ACT, some of the formulas are given. So as far as memorizing these or putting them in your calculator, taking that extra time, not necessary. Okay, you took the practice SAT, you saw that some of the formulas were given. That's definitely counter to what the ACT does. So perimeters of rectangles and squares, clearly you've seen this formula before, but 2L, 2W, area of a triangle, okay. Our area of parallelograms, areas of other polygons, area angle polygons, all these formulas are definitely useful, definitely something you want to review. Angles in a polygon of different size. However many triangles can go into that polygon determines the number of angles. So if there's 6 sides like this one has, you see that that's 4 triangles. 4 times 180 gives me 720. And then basically you do that enough times, you come up with this theorem. It's just the number of triangles is always 2 less than the number of sides times 180. And then you get into some examples. Take your time, look at these if you want. Areas, examples, taking a look. Circles, some important formulas. Again, a lot of these are given to you, but the idea of parts of a circle are definitely going to be tested. You got to know what a diameter, radius, arc. All this is good stuff to review. I don't have to go through it all with you. Circumference of a circle, you see this formula down here. That's one of the things I would just remember, pi d or 2 pi r. All right, area of a circle, same concept. Area of a circle, I would say, is something you just got to remember. Although they may give it to you, you just, it's one of those formulas that I would say just put in your brain and just don't forget. Pi r squared is the area of a circle. All right, walking through this, solid geometry, start talking about volume. Get into volumes. Essentially, volume of a shape is the area of the base times the height. So when I look at these ones down here, you just find the area of the base, which in these cases is a triangle, in this case is a hexagon. You multiply times the height to find the volume. That's how you find the volume of prisms and cylinders. Simple formula for the volume of a box is just LWH, length times width times height. All right. Other formulas like these will be given to you pretty much. I've seen these on SATs, so you can pretty much bank on these ones being given to you if you need the volume of those. But again, you could review those things as well. Surface area is the amount of covering that a shape needs, and you kind of think about it like how many faces on the surface. So a cube has 6 faces, all have area x squared, so it would be 6x squared. That's going to be one of the things you might see. Geometric perception is a little bit of a different concept, and basically what the SAT might do is it might ask you to visualize a situation where you might have to think in 3 dimensions. You might have to think like, you might have to look at something like this and determine what shape it might make. So 3-dimensional shapes, visualizations are definitely fair game for the SAT. Okay, here's an example. Coordinate geometry, finding the area of shapes in the coordinate plane, using equations and things like that, all definitely fair game. Might want to review this. Midpoint formula and distance formula, definitely need to know these. Okay, midpoint formula is basically right there. The average of the x values and the average of the y values will give you the coordinate. Distance formula is based off the Pythagorean theorem, and you see that said right here, based off the Pythagorean theorem. But the formula basically listed tells you how to find the distance between any 2 points in the coordinate plane. Again, difference between the x's squared, difference between the y's squared. It always comes out positive because when you square anything, it makes positive. Transformations, okay, once again, transformations as far as equations go are a little bit different than transformations as far as geometric things go. You might talk about a translation moving something 5 units up and 2 units right. So if you want to do that, basically what you do is you look at this shape and you take every coordinate of the vertices, and you just shift those based on what the problem says. You can see some of these reflections, rotations, transformations. In this particular picture, some examples. Reflect an object means like this. Rotate an object means to turn it. Okay. Reflect an object about a line makes a mirror image. So. And another note about rotation reflection is if you rotate something like a rectangle, say 180 degrees, it basically ends up exactly the same if you rotate it about a center point. Different things that pop up, rotating something a certain number of degrees, 90 degrees, obviously results in this shape here, standing straight up. So hopefully, walking through this helped you to get a little bit of review and at least make you see what's going to be on the SAT that maybe you need to review a little bit better.